Hi everyone, welcome to our video on the three kinematic equations. These are three equations that are really important to us throughout the year, and they allow us to make predictions about how objects are moving and how far they're going to move. And they are valid for any situation where there's a constant acceleration. So when we use these equations, there's going to be five different variables that we have to always consider. There's v subscript I, which is the initial velocity, vf, which is the final velocity, a is acceleration, t is time, and d is for displacement. And you could replace that with an x if you wanted. But here are the three equations. Equation number one is vf equals vi plus a times t. Equation number two is vf squared equals vi squared plus 2 times a times d. And our final equation, number 3, is d equals vi times t plus 1/2 a t squared. And those are three really important equations that we can use to solve problems. What I wanted to do right now is just kind of go through two examples of how we use them. That's the best way to learn. So when you're reading a word problem, I would list the givens first. So this is a train moving at 50 meters per second, so that's its initial velocity. So I'm going to write that down. Decelerates at a rate of 3 meters per second. There's a mistake in my presentation. Take some points off. Let me take some points off. Crayon, maybe, -1 for me. A equals -3 meters per second. You notice I put in the negative because this object is decelerating. And to show velocity coming away, we want to put in a negative. It reaches a final velocity of 12 meters per second. So that's Vf equals 12 meters per second. And the problem says, how far distance or displacement does it travel during this deceleration? So we want to find d. So if we look at these, the things that we're given and what we want to find out, we have vi, a, and f, vf, and we want to find d. The second equation is our best option, vf squared equals vi squared plus 2 times a times d. And solving this for d, we subtract vi squared from both sides and divide by 2a. We end up getting vf squared minus vi squared divided by 2 times a. And next step in ESNA is to plug in the numbers. So 12 squared minus 50 squared divided by 2 times -3. And I'll get out my calculator. You can get yours out. See, divided by 2 times -3. And I end up getting an answer of 392.67 meters. And so that's how we would do a kinematic equation problem. To do a second one, just to see a different one, it says a car starts from rest, which means its initial velocity is 0, and accelerates at a constant rate for 8 seconds. So we're given time, 8 seconds. The car travels a distance of 150 meters. Over that period, what is the car's acceleration? We want to find acceleration. If we look at the things that we're given, vi, t, d, a, the best match for this is our equation number 3, vit plus 1/2 a t squared. And because the initial velocity is 0, this first term actually goes to 0 because 0 times 8 is still 0. So we're left with the equation d equals 1/2 a t squared. And if we solve that for acceleration, we end up getting 2d divided by t squared. And we can plug in the numbers. 2 times 150 divided by 8 squared. And let's see what we get for an acceleration. I'm going to go to the calculator quick here. Divided by 8 squared, and I get 4.69 if I round. 4.69 meters per second. approximately answered. And those are just two quick examples of many examples that we'll do using our three kinematic equations.